This is Module 1 exam or Skills exam for ECEA103L, Section B14. I'm your host, Gian Duhina, 2016 14 23 86 from ECE 2. I'm here to discuss the SCR phase control circuit. In AC circuits, the silicon controlled rectifier or SCR can be turned on by the gate at any angle alpha with respect to the applied voltage. The angle alpha is called the firing angle. The power control is obtained by varying the firing angle, and this is known as phase control. Now, I am going to create an example circuit for SCR phase control. So, first, we need to have a AC voltage source, a two resistors, and one for load resistor, and potentiometer, one diode, and one thyristor. So this thyristor will consider as a as SCR component. So we need to design this. We need these components to design an SCR phase control circuit. And we need to connect them all respectively. So the AC the AC voltage source will connect to the R1, and the R1 will connect to the potentiometer, and the gate and the potentiometer will connect to the diode, and the diode will connect to the gate terminal of the thyristor or SCR. So the negative polar for the AC voltage control will connect to the R2, and R2 will connect for the remaining of for the pin of VR1 or potentiometer. Then the anode will connect to the R1, and its cathode will connect to the load resistor, and the load resistor will connect to the R2. So we almost forgot to put an ground. So to test the circuit and to see the graph of the firing angle, we need to have the test equipment here with the virtual instruments and put the oscilloscope. So we will connect the positive for the positive pin of the load resistor, and the negative pin of the oscilloscope to the negative pin of the load resistor. So we will label R3 as RL1, and label the thyristor as SCR1. So to see the graph, we need to add a graph here to show the graph for the firing angle of the load resistor. And save it as SCR phase control circuit. So, from the circuit that I designed, the gate triggering voltage is derived from the AC supply through resistors R1, R2, and R3. The variable resistance R2 or the potentiometer limits the gate current during positive half cycles of the supply. If the moving contact is set to the top of resistor R2 or the potentiometer, the resistance in the circuit is the lowest and the SCR may trigger almost immediately at the commencement of the positive half cycle of the input. If, on the other hand, the moving contact is set to the bottom of resistor R2 or potentiometer, resistance in the circuit is maximum. The SCR may not switch on until the peak of the positive half cycle. By adjusting R2 between two extremes, SCR can be switched on somewhere between the commencement and peak of the positive half cycle. That is between 0 degrees to 90 degrees. If the triggering voltage is not large enough to trigger SCR at 90 degrees, the device will not trigger on at all, because the triggering voltage has maximum value at the peak of the input and decreases with the fall in voltage. The operation, sometimes referred to as half-wave variable resistance phase control. It is an effective method of controlling the load power. Diode is provided to protect the SCR gate from the negative voltage that would otherwise be applied during the negative half cycle of the input. It can be seen from the circuit diagram that I have just created that at the instant of turning on of the SCR gate, current flows through RL and the diode. So we can see here in the simulation, if we can simulate it, if we put the potentiometer at 0% and create the graph to fit the data, we can see that the angle is lower than the angle is at 0 degrees. But if we raise the percent of the potentiometer, so if we can raise the percentage of the potentiometer at 45%, we can see that the half angle or the 90 degrees has been committed. So we can see that the higher the percentage of the potentiometer, we can see that the angle is creating a perfect angle that is raised to 180 degrees. So, overall, this is an example of SCR phase control circuit, and this is the graph or simulation graph of the SCR phase control circuit that I just made.